Hi guys, so let's talk about section 8.1. um, this is actually kind of review from maybe Algebra 1, maybe even pre-algebra. Definitely did this in geometry as well, so you've done this a lot, even recently as last year. But yeah, so we just want to do some basics for chapter 8.1, distance formula, midpoint formula, and then some problem solving. Some of the problem solving is pretty difficult. You'll see the last example is pretty hard, but please get that. You need to have this down very, very well. Since you've done it so many times, it's not really a matter of trying to memorize a formula. We're assuming you already know the formula. It's more of, do you really understand in depth how this works? Okay, so the midpoint formula, distance formula, you need to have an in-depth understanding of this. And we're doing two, what we call proofs, not really proofs, but a little bit of a verification of the formula that it works. Okay, and these things you need to be able to do on your test. You need to know how to show that you understand how these formulas work. So this little box here where it says the distance formula, we're not just giving it to you, you have to be able to derive it yourself. And in the midpoint formula, you also have to be able to derive that yourself. And this will be on your test as well. So make sure that you are very, very good at knowing how this works. Okay, so the distance formula, basically the question is, use this diagram that's given to you to find the general formula for the length or distance of any segment D. Okay, so we're talking about any line segment D. The formula works for that. So find the formula for this. All right. So here is what we can do. Now, if you look at this, we gave you this picture in a very specific format. It would be different if I just said to you, here's a segment and prove the distance formula. That would be a bit harder. So we are giving you a diagram that kind of helps you because you see a right triangle already there. And so but probably the first statement you can make here is by using Pythagorean theorem, because we gave you a right triangle. You can say by Pythagorean theorem. Okay, you can say what? What can I say by the Pythagorean theorem? So you must state what you're using to make your justifications. I'm using the Pythagorean theorem, and that says that basically the hypotenuse squared is equals to this squared plus that squared, the two legs squared. So you can say something like d squared equals to a squared plus b squared. All right. Now that's not new. You've known that forever. All right. Now somehow I need to tie this into how can I find actual length if I had numbers. So if I had numbers for these coordinates, how would I actually be able to find the length of the segment? Okay. Now keep in mind, I'm assuming you actually know the distance formula because you've done it so many times. So the distance formula, again, let me give you a little hint here, is this. This is the distance formula. Okay, this is the distance formula. So that's what we're trying to come up with. All right, so this is a good first step. D squared equals that. Here's a squared term. Here's a squared term. Great. Okay. How do I make it? How do I make my statement fit to the distance formula? So all you have to do is say, okay, I have a and b. So d squared equals a squared and b squared. But what is a? What is a equal to, and what is b equal to? What is the length of that segment? So you can see here, since the y coordinate remains the same from here to here, from x1 to x2, okay, this segment right here, which is A, since the y coordinate remains the same, it's a perfectly horizontal segment. Okay, so something you learned in geometry a long time ago was that the definition then of length is just the bigger coordinate, which in this case would be x2, minus the smaller coordinate, which would be x1. So we can actually answer this fairly easily. Okay, it is x2 minus x1. All right. So you can write something like the length of A is x2 minus x1, or A equals x2 minus x1. And so it's implied, we're not doing a real detailed proof here, but it's implied, what do we mean by D and B and A? We mean the length of those segments, okay? That's implied here. All right, so we have this, and then likewise, for letter B, we have a similar thing. What is B? Well, since the x-coordinate here remains the same for this segment, okay, since the x-coordinate remains the same, it's a perfectly vertical line segment. So to find the length of the perfectly vertical line segment, I just subtract the y-coordinates from each other. Okay, so B is just y2 minus y1. All right, so you can say, and the length of B is y2 minus y1, or B equals y2 minus y1. Okay, so there's my second part of my quote-unquote proof. All right, so all we have to do now is say, wait, this is starting to look a lot like the distance formula. I have x2 minus x1, and I have y2 minus y1. So all I have to do is say, how about I do a substitution? So let me use a different color here. How about I substitute this and this into my original formula that I came up with? So if I substitute this in here and I substitute this in here, then what do I have? Let's look at that. Okay, so I'm going to write that. So let's say we substitute our values for A and B into the original equation. What do we get? Okay, so if we substitute this into our original equation, what do we get? So we get, let me try and do some colors here. D equals, and what you'll get is something squared plus something squared. And let's do the substitution in red. So A, instead of A, I'm going to put this, x2 minus x1. And instead of B, I'm going to put this, y2 minus y1. Well, wait, that's very, very close to the distance formula. Very, very close. Okay, so all I need to do now is say, oh, just take the square root of both sides. Okay, so take the square root of both sides. And so what I get is, if I take the square root here, then I take the square root here, I get the square root of a square cancels, okay? But this does not cancel because I have a plus in between the two terms, okay? So I just have this, x2 minus x1 squared plus y2 minus y1 squared. And that is the distance formula. That's what we set out to prove. Okay? And this is not really a very rigorous geometrical proof. It's just more of a derivation, a way you can derive the formula. But that's okay. That's good enough for our class. Okay? So, there we have it. All right? So, this is something you should be able to show. If I give you a segment, you should be able to show, hey, the segment's length is that formula right there. Not just memorize the formula, you should be able to derive it. Okay? So then we're going to use this formula to do some examples. So once you understand the formula, then doing the example should be pretty straightforward. So I'll do example 1A. I don't think I will do B. It's the same thing over again. we'll probably just do example 1a and then move on to example 2, which is it's the same thing many times over. Okay, so just a basic one here. If you have 2 points, label the smaller x coordinate x1 and then the bigger x coordinate x2, and then just do the same for the y. Okay, just so if you call this point x1, then you must call this point x2, and then this must be y1, this must be y2. And the normal question students ask is, can I switch the points around any way I want to? And yes, that's true. So even if we switch the points around like this with a different segment and a different coordinates, the formula will still work. Okay, it still works. So that doesn't actually matter. You can still switch it around. All right, so all we have to do now, since we've done the hard work of finding the formula, I just trust the formula. D equals root, and I think you should probably write this down a few times while you're learning this again, or reviewing it, I guess I should say, and then just plug stuff in. Okay, so now we can just do this. X2 is 4, so let me do 4, and then x1 is -3, okay, and then there's a minus here from the formula, and I'm squaring that, plus something else squared, and there's a minus, and I just have to substitute in my y's. So y2 is -1, and y1 is 5. Okay? And so here's what I have. Let me switch back to red. What I have is square root of, now this is 4, negative becomes a plus, so 4 plus 3 is 7 squared, plus -1 minus 5 is -6 squared. Negative squared is positive, so that would be 6 squared. Okay? Or let's do it this way. Let's do -6 squared. Maybe that'll make you happier. And then we get this. That's the square root of 7 squared is 49. -6 squared is positive 36. And that's root 85. Most of the time, you don't have to. A question like this, don't make this a decimal. That's not important. If it's a word problem or something like that, sure. Want an actual length, you can take the time to do that. So there's this. Okay. So that's the answer for that. So then the next one is example 2. Says something a bit more dense and rich, okay? And this is a question that involves a lot of distance formula. The vertices of a triangle are this, and this, and this. It says classify, oh, interesting, actually that says calcify, interesting. Classify triangle RST as scalene, isosceles, or equilateral. You can draw the picture for this if you really want to make yourself comfortable with what's going on. R is -1 and 3. Okay, so that would be point R, -1 and 3. And then point S would be 1, 2, 3, 4, 5, and 2. Okay, 5 and 2, that's point S. And then point T would be 3 and 6, 1, 2, 3. So 3 and 6 would be up here. This is point T. Okay, so there's my triangle. Now, you might be tempted to just go, oh, I know that it's scalene, or it looks isosceles, or something like that. Our perception at judging what type of triangle this is pretty bad. Okay, so you don't want to just write, oh, it's scalene, look, my picture. You can't do stuff like that, okay? You have to mathematically show that it's scalene. So, and again, what does scalene mean? Scalene means none of the sides are equal. Isosceles means 2 of the sides are equal. Equilateral means all 3 of the sides of the triangle are equal. Okay? So what we have to do to answer the question is find all of the sides, lengths. So what I have to do, let's say I'll do RS first. Let's say we do this one. Okay. So RS, and we find that length. Okay. So RS is the square root of, and we need to decide which point is x1 and which point is x2. Since this x value is smaller than this one, I'm going to call this x2 and this x1 when I'm trying to find the length of RS. Okay, so for RS, I just do x2, which is 5, minus x1, which is -1 squared, plus, and then this has to be y2, and this has to be y1. So 2 is my y2 minus 3 squared. Alright? And I'm going to go much faster here because, like I said, I'm assuming this is all review for you. Okay? Alright, so that's RS. So let me erase this stuff. I did RS. This was all just to find RS. Okay? So now I want to do the next one. So we did that one. Let's do another one. Let's do ST. Let's just go in order. RS, then ST, and then we'll have to do RT last. Okay? So let's do ST, which is this one. And I'm going to assume they're different lengths until we show otherwise. So that's why I'm using 2 tick marks there. Okay? So ST, and in this case, I'm going to say again, this x1 is smaller and this x2 is bigger. So I'm going to call that x1, x2, and y1, y2. Okay, so I'm going to do 5 minus 3 squared plus, and then 2 minus 6 squared. Okay, and that gives me, if you do that, you get 4 plus 60, and that's root 20. And you can simplify this using radical form, that's 2 root 5. Okay, so we were correct with our annotation here. This is not the same length. Root 37 and 2 root 5 not the same thing. Okay, and then gets to the third one, which will be RT. Okay, which will be RT. And so let's do RT. RT would be root, and let's make this x2 and x1 again. So you're doing 3 minus -1 squared plus 6 minus 3 squared. Okay, and that would give me 16 plus 9, right? Which is root 25, which is 5. So annotations hold. Every side is a different length. Okay, so you can say something like, since RS is not equals to ST is not equals to RT, triangle RST is scaling. Okay, and just remember a little note from geometry class. RS means the length of segment RS, and RS is the segment itself. Okay, those are different things. So when we write RS like we did here, or ST or RT, that implies the length of the segment already. Okay, this is geometrical notation. Alright, so that's that. Then let's talk about midpoint formula. Now midpoint formula, you should remember, midpoint formula is usually a thing that students think is very easy. And midpoint formula is basically this. The midpoint is x1 plus x2 over 2 and y1 plus y2 over 2. Okay, so that's fine, but what you have to be able to do in this class is show how you can come up with that, derive it yourself. This is not good enough to just memorize a formula and write it down. You've done that so many times, and so what you have to do is somehow show that this one right here is the midpoint. Okay, that's the midpoint. And so you have to do some justification here. Okay. So what we want to do is say something very specific. Something very specific. So we have to say, okay, if I show it's the midpoint, I have to show something like this happening. So I have freedom. What is this point? X sub m, y sub m, what is that? Okay. So what we're going to do is say, now I don't know that this is the midpoint of the segment, but I'm going to say, if this is my one distance, all the way down here, and this is coordinate is x1, and this coordinate down here is x2, what I'm going to do is say, let this point here, okay, be the middle of those 2 points, okay? So let it be halfway between them. Now, that doesn't mean that this is equal to this. I'm not assuming the answer of my proof for it. That's not what I'm doing. I'm saying let this coordinate here be x2 plus x1 over 2. Let it be the average of those two coordinates. Okay? That's what we're doing. And then let's say here, I'm saying let this point be the average. So now I have to do this. Say, oh, this coordinate is y2, this coordinate is y1, and I want to show that that's the average. Okay? So now I'm going to do, this is y1 minus y2, y1, yeah, plus y2 over 2. Okay? That's what I have there. So remember, average again is adding up the number of numbers and dividing them by the number of numbers. Adding up the numbers and dividing by the number of numbers. So I have two coordinates, I'm add them together and divide by 2 because there's two coordinates. Okay? That's average. So what I've said now is that basically, now I'm going to draw a triangle here to show you something. Okay, and then we'll start writing stuff down in words. So please, you must have explanations in words. Okay? So what we've done now is this. We've said that if this point is the middle of this segment right here, okay, if this point is the middle of this segment right here, okay, then this and this is the same. All right? And likewise, if this point is the middle of this segment right here, okay, then this and this are the same. So this point is the middle of this segment, and this point is the middle of this segment. Then I know that this piece is equal to this piece, and I'm using geometric notation here, and this piece is equal to this piece. All right? Okay. And then likewise, of course, if this is a perfectly horizontal segment, then this piece is also equal to this piece. All right? So I'm doing a very roundabout way here to show you something, and that is, you can't just go and say, oh, the middle of the segment is the midpoint. Nope, that's not what we're doing. We're saying, if I choose x sub m to be that point, and I choose y sub m to be that point, okay, does that show me that the point x sub m, y sub m is the midpoint? The answer is yes, but actually you have to justify that somehow. And the way we justify it again is Pythagorean theorem. Okay, so what we have here is a right angle and a right angle. And so what we've just done is basically said that this side and this side is the same as this side and this side. That side and that side are the same. Oh, let me make it look like one. And therefore, the hypotenuse of each of these triangles must be the same. So because of my choices here, okay, because of my choices here, Pythagorean theorem says that those two segments are the same. And if this is the same as this, then I know that x sub m, y sub m is the midpoint of the segment. Okay? So we have to do this, and we have to say, write some words. So choose x sub m, y sub m, such that, okay, you have the choice to choose such that x sub m is the average. Oh, that's not right. x1 plus x2 is the average of the distance between x1 and x2, okay, and y sub m equals y2 plus y1 over 2, okay. Then you can say something like, as illustrated in the graph, you can say that as illustrated in the graph, by Pythagorean theorem, okay, you can say that a sub am, which is this segment right here, the length of a to m, okay, a to m, okay, am is the same length as mb, okay, which implies that m is the midpoint of AB. Okay? There's some logic going on there, and this is, again, not a rigorous proof or anything like that. We're just doing some derivation. It's a little bit better showing that you understand what you're doing than just memorizing the formula. Okay? And so then we can say that, therefore, m, which is x sub m, y sub m, must be equal to x1 plus x2 over 2 and y1 plus y2 over 2. Now, I think if you look at my completed note sheet, I have a completely different way of proving this. But that's okay. This is a different way. Okay, I never used to use the average approach. I did it slightly differently. That's actually more complicated, but maybe a bit better. Okay, but this is sufficient for our class. We're not really doing a rigorous proof because we're not proving that these are right angles and all that kind of stuff. We're just loosely showing that I know what's going on. Okay, a little bit better than memorizing just, hey, there's midpoint formula. At least you know where it comes from and how you can at least justify its existence a little bit. Okay, so this is something you should know. You should be able to reproduce that on a test. Okay, I'm pretty sure it's on your mid-chapter 8 quiz. Either this one or this one. You should know both of those. All right. So let's use midpoint a little bit. We'll do example 3 and 4, and then I think I have a completely different video for example. Ooh, there's a numbering mistake. This should be example 5, I guess. Okay. I think I already have a different video for this on Schoology, so I'm not going to make it part of this video. I think it'll be separate. And if that's not the case, then I will make a new video for example 5. Okay. So now that you know the formula, here's the question: find the midpoint of the segment. Okay. So again, I'm not going to do 2 of these. This is something you've done many, many times. Let's call this x1, y1, x2, y2. You can switch that around, doesn't matter, as long as if this is a 1, this is a 1, that's a 2, that's a 2. Okay, that's all that really matters there. And then you just plug it in, and usually we write it like this. The midpoint is, okay, and we just write, maybe you should copy down the formula, just since we're reviewing. Okay, y1 plus y2 over 2, just because we're reviewing. And then you plug in things. Okay, so x1 is negative 5 plus x2 is negative 1 over 2, comma, y1 is 1 plus y2 is 6 over 2. So the midpoint here is negative 6 over 2, comma, 7 over 2, and that would be negative 3, 7 over 2. Something like that. Okay? So there's midpoint there, and then, this is an interesting question. Words here you haven't seen in a long time. Okay? Use point slope formula, we have to review that, to write a linear equation for perpendicular bisector. Do you remember what that is? Of the segment that conjoins those 2 points. And then be sure to write your answer this way. There's a lot of information here. Okay, so point slope formula. Let's refresh your memory. Here's point slope formula. Let me use a different color. This is y minus y1 equals the slope times x minus x1. This is point slope formula. Okay, right there. Y minus y1 equals x m times x minus x1. Okay, that's point slope formula. Alright, and then perpendicular bisector means a segment that bisects another segment and is perpendicular to it. Okay, so if this is my segment, the perpendicular bisector does this. Okay, it cuts that segment in half, exactly at a right angle. Alright, and then this one is called slope intercept form. Okay, so this is a lot of stuff going on here. So let's draw a picture. I have my segment AB, and I want to find the perpendicular bisector of that. So let's draw segment AB, and let's say 1, 2, 3, and 1, 2, 3, 4. So here is point A, which is negative 3, 4, and then point B is 1, 2, 3, 4, 5, 1, 2, maybe there. Okay, something like that. So point B is 5, 6. Yeah. Okay, and so here's segment AB. That's segment AB. We're asked to find the perpendicular bisector. So I'm going to draw roughly what's going on here. Okay, I think it looks like it might be over here, the perpendicular bisector, maybe, and perpendicular bisector would look something like this. Okay, something like that, so that these two are the same. Okay, now the question is, find this line and find the equation for it in slope intercept form. Okay, that's the question, perpendicular bisector. So now I have to do the work to do that. So what's your strategy? All right, you know that this segment here, okay, the perpendicular bisector, has to bisect going through the halfway point. Oh, that's what bisector means, halfway point. So I know that this is the midpoint. Okay, so I have to find the midpoint. All right, good. If I find the midpoint, then I have a point on this line. Okay, so I have a point on this line if I find the midpoint. Good. And then, wait, there's a hint here. Use point slope formula. If I have, no, I've annotated that too much. If I have a point, check, a midpoint on the segment, then all I need is the slope and then I can find the equation of the line. Okay, so let's do that part first. Let's first find the point. Okay, we said it's the midpoint right here. Let's find the midpoint of AB, and that'll give me a point on the perpendicular bisector. Okay, so all right, so midpoint. So let's say find the midpoint. Find the midpoint of AB. Okay, and that's not too difficult to do. The midpoint is, and we just do again, x1 plus x2 over 2 and y1 plus y2 over 2. And if I do that, I get what? I get 5 minus 3, okay, over 2, and I get 6 plus 4 over 2. Okay, so 5 plus negative 3, which is 5 minus 3, and 6 plus 4. Alright, and so that gives me the midpoint is, what's that? 2 over 2, which is 1, and this would be 5. Now my picture, this looks right. 1 and about 5. Yep, that looks right. Okay, so we found the midpoint. The midpoint is exactly that. Ooh, let me write. M is 1, 5. Okay, so now I have a point. This is a point on the perpendicular bisector. Good, that's a good start. I have a point. Now I need a slope. Now to find a slope, I need at least 2 points on a line or a segment. I don't have 2 points on the perpendicular bisector. I only have the 1 point we just found. Okay? So, but another fact from geometry is, and from Algebra 1 as well, is that if 2 segments are perpendicular, their slopes are negative reciprocals of each other. So we can do this and say, let me do a different color. We can say number 2, okay, if I can find the slope of this segment and then take the reciprocal of it and multiply by a negative, then I have the slope of this segment, this line. Okay, so what we do is find the slope of AB first, okay, of segment AB first. And if I find that slope, how do I do that? Slope is another formula that's review. Okay, slope, which we also call M. This is confusing. Okay, maybe I will just write slope so you don't confuse M for midpoint and M for slope. So let's write slope is, and here was the formula you learned a long time ago. Okay, y2 minus y1 over x2 minus x1, which is also the same as rise over run. Now, since we went to the time to draw the picture, you can just counter the slope by doing rise over run. Okay, or you can plug in the numbers. Either way is fine. Okay, so I'm going to assume that most people are going to want to plug in the numbers. Okay, so if you want to plug in the numbers, we can call this y2 and we can call this y1. Okay, so y2 is 6. Okay, and y1 is 4 over, and then x2 would be 5, and x1 would be negative 3. 5 minus negative 3. So what this would give you is 2 over 8, okay, which is a fourth. Now, if you could do 2 over 8 straight from counting, you can say from here I go up 2 units, and then I go over 8 units, okay? So you could have done that a different way. Any case, so there I have my rise over run, and then that's not the slope of the perpendicular bisector. Then you say, oh, okay, that's that. That's the slope of this segment. This slope is 1 over 4. I want this slope, okay? But since we know that we're looking for the perpendicular bisector slope, we just say the slope of the perpendicular bisector is this, okay? It's multiply, it's 1/4, let me do 1/4, okay? Oof, let me erase that. It's 1/4 times a negative and make it the reciprocal. Ooh, that's hard to write, okay? Let me write it in words, and then we'll just write it down. Is the negative reciprocal. Of the slope of AB. Okay, so I take the reciprocal and make it negative. Okay, so the negative reciprocal slope then is -4. So I just did it. This slope is -4. If this is my slope of my segment, the perpendicular bisector slope is -4. Okay, make it negative and take the reciprocal. So now I have the information I need for point slope formula. Now I can do it, my work. Number 3 is, let's write the equation. Okay, let's write the equation. So I use point slope formula, and for point slope formula I need a slope, which we found, here it is, okay, and I have a point, which we found, here it is, okay. So use the midpoint and slope to find the equation of the perpendicular bisector. Alright, so we do that. Here we go. Here's point slope formula. Y minus y1 equals the slope times x minus x1. Okay? And we're going to plug stuff in. So if I do that and I plug stuff in, now I have to choose a x1, y1 on the perpendicular bisector. Well, this is the only point I have on the perpendicular bisector here. Okay, so I'm going to call this my x1, y1. So I'm going to call this y minus y1 is 5 equal to the slope, and I'll do that in a second. And then my x1 is is x minus 1. And now I have to plug in my slope. So what's my slope? My slope we found was 4. Okay, my slope is, -4. So my slope is -4. So actually this is the answer. You found the equation of the perpendicular bisector. This is the equation of the perpendicular bisector. We found it, we're done. Because we have the slope of that line and we have a point on the line, and that's the equation. But the question was, write it like this. Write it in slope-intercept form. So let's write it in slope-intercept form. All I have to do is keep working with this. Y minus 5 equals, and distribute this. Alright? So you get -4x, and you get +4. And then to make it look like that, I just add 5 both sides. So you get y equals -4x plus 9. There's the final answer. Okay? There's the final answer. Alright guys, I spent a lot of time on this stuff. Hopefully that makes sense to you. Let me know if you have any questions.